All right, last question on the practice test. Particle moves along a horizontal line. Position function for s of t is s of t for t is greater than 0. So this is something that is kind of implied sometimes, like the textbook implies it in their questions, but they didn't mention this explicitly. But this is basically saying like we're only starting at 0, like we're not going back in time. We don't have negative time, right? Like we talked about on number 17 with projectile motion, like that -1 as a solution for when the ball hits the ground doesn't really make sense because that's before we threw the ball, right, or before it hit the ball. And so anyway, so keep that in mind. So for each problem, find the velocity function v of t, the acceleration function, and the intervals of time when the particle is slowing down and speeding up. Okay, so remember, slowing down is when the signs are different, when velocity and acceleration have different signs. Right? And then speeding up is when velocity and acceleration have the same signs. So that's V and A, same signs. Okay, all right. So that's what we're gonna do. So first, the velocity function. So V of t is the derivative of the position function, right? So I'm just gonna take the derivative of this. That part's hopefully becoming second nature to you now, right? So just some power rule here. Yeah, derivative of -3t is -3t squared. Derivative of 24t, 2 times 24 is 48. Take away 1 from the exponent, and that's how we get just t to the first. And then the derivative of a constant times a variable is just that constant, right? Okay, so that's our velocity function. Now the acceleration function, I'm going to write it off to the side just so I have space to work below. The acceleration function is the derivative of velocity, also known as the second derivative of position. Okay, and so that's going to be -6t plus 48. All right, so I just took the derivative of this, right? The derivative of the derivative, right? Also known as the second derivative. All right, so that's this taken care of. Find the velocity function, the acceleration function. I just did that, right? Now I'm looking for the intervals of time when the object is slowing down and speeding up. And so remember here, what we need to do is we need to find the signs of velocity and acceleration, right? To see if they're the same or different. So if we want to do that, we want to first figure out where the velocity and acceleration are 0. Okay, so first I'm going to start with velocity. So I'm going to set it equal to 0. And I'm gonna while we're setting equal to 0, I'm just gonna factor out this -3t, or excuse me, the -3, and so I'll end up with positive t squared minus 16t plus, let's see, 48. Okay. All right, and now that I'm here, now I can factor this, right? Once again, you can use the quadratic form at this point. I'm fine with you doing that. And so, okay, and so looking for numbers I can multiply to get 48 that I can add to get 16, right? So that would be 12 and 4. Okay, this tells me the sign of the bigger number. This tells me since it's positive, the signs will be the same. So we'll get -12, -4. And so remember, this doesn't factor into our answer. So it's just going to be t equals 12 and t equals 4. And the reason this doesn't play in is because there's no variable, right? So it's just a constant. Constant can never equal 0. But this can equal 0 when t equals 12. This can equal 0 when t equals 4. So that's why these are solutions there. Okay. So now what we're going to do with that is remember that this tells us where we have zeros, right? So where the velocity is 0. So now we want to make intervals, right? So remember, if we think of a little number line, we have 4, 12, and then we also want to account for 0 here, which, so we'll just put that 0 here because it says t is greater than 0. So we basically have 3 intervals that we want to account for, right? 1 here, 1 here, and 1 here, right? All the way to infinity. And so, so we're only dealing with 0 to positive time, right? So our first interval is going to be 0 to 4. Our second interval is going to be 4 to 12. And our third interval is going to be 12 to infinity. Okay, so those are intervals where velocity is not 0, right? Because we know that the only zeros happen at 12 and 4, right? And so, yeah, anyway, if those are the only zeros, then that means velocity cannot be 0 anywhere else, right? And that means it has to be positive or negative in those other areas, okay? Now, because we did this a different way, if you put negative infinity here, that's totally fine. That's how we did it on the board, an example for class, because they didn't say this explicitly, and that's how we probably did it in the video as well, okay? So that's okay if you have that. Yeah, if you have negative infinity here, I'll give you full credit. All right, so now I want to figure out the signs of velocity in these intervals, okay? So for 0 to 4, I just want to plug in something to our velocity function that is between 0 and 4, right? So like 1 is a good example, right? So I'm just going to do v of 1. And you could choose anything between 0 and 4. Just make sure don't choose these endpoints, right? Don't put in 0, don't put in 4. Actually, 0 wouldn't be bad to plug in because 0 is actually not one of our solutions for when the velocity equals 0. So actually 0 wouldn't be bad. Okay, but I'm just going to do 1 just to not confuse you with that. Don't use the endpoint. All right, so if I plug in 1 here, I'm going to get negative 3 times 1 plus 48, which is 45, minus 144, right? So 45 minus 144 is negative, right? I don't care what it is exactly, but it's going to be negative. So velocity is negative. These are two ways to say velocity is negative, right? You don't have to necessarily write both of those. All right, so velocity is negative in that interval. Between 4 and 12, I'm going to plug in, I could plug in 5. Let's do 5, so v of 5. So if I plug in 5 here, I can just maybe do that on my calculator. Negative 3 times 5 squared plus 48 times 5 minus 144. So let me do that on my calculator real quick and see if it's positive or negative. All right, it came out positive. So positive velocity here. And then between 12 and infinity, you could do 13, I don't know, 20, 100, like pick some numbers that are either easy to plug in or easy to work with. So let's just do, I don't know, 20. Okay, so v of 20. I just want to plug that in and see if it's positive or negative. So I plug that in my calculator, it comes out to negative. All right. Okay, so I checked in each of these intervals. Remember, I didn't use the endpoints. I used something between the endpoints, right? And I found these. So now I need to figure out whether the acceleration is positive or negative in these intervals, right? Excuse me, first I need to find the intervals for acceleration and then compare them with these for velocity, okay? So what I'm going to do is I'm going to set acceleration equal to 0. I don't have to factor because this is just linear. So it'll be 6t. If I add 6t to both sides, 6t equals 48. I can divide by 6 on both sides. And so it ends up being t equals 8, right? Okay, so now we're going to have two intervals, right? Because if we think about this on a number line, and if 0 is our initial time, so we have an interval from 0 to 8, and then we have an interval from 8 to infinity. And so we're going to have 0 to 8, and 8 to infinity. Okay, and now once again we want to figure out what the sign of acceleration is, right? So I'm going to plug in something between 0 and 8. You could use 0 in this case because it doesn't actually produce a 0, but we'll do 1 again. So a of 1, if I plug in 1 here to the original function a of 1, then that would be negative 6 times 1 plus 48, which is positive, right? So a is positive here. In this interval, I can plug in anything greater than 8. I'm going to do 10 just because 10 is a little easier to work with than 9. So if I do negative 6 times 10, that's negative 60 plus 48 is negative. And so a would be negative, right? Okay, so now I want to compare when the velocity and acceleration have the same signs or different signs. Okay, so I'm just going to start with these velocity intervals. So this first interval here, 0 to 4, that whole interval fits in this interval, right? So that means that whole time from 0 to 4, velocity is negative and acceleration is positive, right? And so that means 0 to 4, that whole interval is going to be speeding up or slowing down, right? It's going to have the same, that same dynamic the whole time, right? So let me write speeding up, slowing down, right? So the whole time from 0 to 4, we just covered this, but just to reiterate, our velocity is negative while our acceleration is positive, right? So the signs are different, therefore it's going to be slowing down. So from 0 to 4, that object is slowing down. Okay, now we're going to look at this next interval from 4 to 12. Where does that interval fit? Does it fit here or does it fit here? And that's a trick question because it's both, right? It overlaps. And so when it overlaps, that's when you have to break it up into two. Okay, so we're going to go from 4 to 8, which is where acceleration changes. And then we're going to start up at 8 and go all the way to 12. Okay, so we had to break this interval up because 8, that point where acceleration changes, is in the middle, right? Okay, so for both these, we know velocity is positive, but from 4 to 8, velocity is positive while acceleration is also positive, right? All the way up until 8. So they're both positive, so that means it's going to be speeding up, right? Because velocity is positive and acceleration is positive, right? For 0 to 4, velocity was negative and acceleration was positive. All right. Okay, now let's go to 8 to 12. So we know velocity is still positive, right? Everywhere from 4 to 12. So from 8 to 12, velocity is positive, but acceleration is negative, right? And so that means it's going to be slowing down because they're going opposite. They have opposite signs. So velocity is positive, but acceleration is negative. All right, and finally, where does 12 to infinity fit? 12 to infinity all fits in here, right? 12 is greater than 8, so it's going to fit all inside here. And so that means we can use this whole interval, 12 to infinity. The velocity is negative, and the acceleration is also negative, so therefore it's speeding up, right? So we go from 12 to infinity, where the velocity is negative and the acceleration is negative, and so it's going to be speeding up. So those are our answers there. All right, so that problem definitely, it starts out not too bad, like the velocity. Finding the velocity isn't too bad. Finding the acceleration is not too bad, but definitely slowing down and speeding up is a good amount of work and time. So once again, I'll consider that kind of in the challenge stretch category, the 10%. So I probably won't give you both or all of like 17 and the second part of 18. I'll probably either kind of mix those together, or they'll be, kind of smaller portions or something like that, okay? Or maybe one part of one or the other will be a bonus.